Hello, I'm Mrs. J, and we're going to talk about modules 10 and 11 and polynomials of higher degrees. We're working with their graphs. So this first part, finding the zeros and their multiplicity of a polynomial when it's in a factored form. You have 4 times x minus 7, x plus 5, x minus 13 squared, and x plus 9 cubed. So when you're finding the zeros, you're setting the function equal to 0. It's your x-intercepts. This is just a constant, so we don't have to worry about this one. So then we have x minus 7 equals 0. That gives us 7. And the multiplicity is the exponent, which is a 1. The next one, x plus 5 equals 0, gives us a negative 5 when we subtract it. And its degree is also 1. And then x minus 13 equals 0, gives us 13. Its multiplicity is 2. And the last one, x plus 9 equals 0, gives us a negative 9. And its multiplicity is 3. These are important because they let you know what the graph does. When it's odd, it crosses. When it's even, it touches the graph. But for right now, they just wanted the multiplicities. So 0 multiplicity 1 would be 7, negative 5. This one's 13 is multiplicity 2, and negative 9 is multiplicity 3. Try one more. Eight x cubed, x minus 7 squared, x minus 9 to the first, and x plus 11 cubed. Just for a little practice, the degree, this would be 3, 4, 5, 6, 7, 8, 9. So the degree is 9, which means it's odd. This is a cubic function. And it's increasing because this is positive. This one, 1, 2, 3, 4, 5, 6, 7. This is also odd, and this is positive. So it's also a cubic function. For zeros and their multiplicity, setting x equal to 0 or x cubed equal to 0, you only need the x, just like we take the inside of the quantity. This gives you 0 with a multiplicity of 3, the exponent. This one, x minus 7 equal to 0, gives us 7 with a multiplicity of 2. Coming from the exponent. X minus 9 equals 0 gives us 9, and the exponent is 1, which is the multiplicity. And x plus 11 equals 0 gives us a negative 11, and the multiplicity is 3. So these multiplicities are just the exponents that are on it. Matching graphs and their polynomials. Okay. So we want to match the graph with their polynomial. Well, if we look at this one, the first one, we have negative 2x to the fourth plus 8x squared. Well, we know it's a parabola because its degree is 4. It's a negative, so it's both going down. Well, that takes out A. It could be B. That's It could be B and it could be F. I don't know how many graphs there are. Yeah. So B and F, because they're the only two that are both going down, because it has to be like a parabola. It can have some bumps in there, but they both go down. So it's B or F. Well, let's look at the difference. Notice at 0, this one's way down here, where this one's at 0, 0. So plug in 0 and see what happens. If we plug in 0, -2 times 0 to the 4th plus 8 times 0 squared is 0. That gives us the point 0, 0. 0, 0 at the origin is this one. This is 0 and a large negative number. So this one was F. They will give you enough to find the information that you need. So the next one is 3x times x squared minus 4. Okay. The degree. The degree is 3 because we have x squared times x to the first is x cubed. So our degree is 3, which means it's the snake. This is positive, so the snake is going up. Well, that could be A because it's going up. C is going up, D is coming down, and the other three are even. So it has to be A or C. We'll see what's the difference in them. Well, they're both going through the origin this time, so that's not going to help us. Maybe if we plug in -1, notice -1 is negative here, but positive here. So plug in a -1. 3 times -1 times -1 squared minus 4. Three times -1 is a -3. Here we have 1 minus 4 is a -3, which gives us a positive 9. So it's -1, 9. -1, 9. This one would work. This one at -1, we're down here. So it would have to be C. Let's try another one. So we have a -x cubed minus 2x squared plus 8x. Okay, cubic graph going down, going down. So this is even, because to be odd, they go in opposite directions. D and E are both going down. I always like the origin if possible, and notice this one's at 0, 0. This is at 0 and a positive number. So plug in 0. So if we plug in 0, zero, 0, 0. So what's the point 0, 0? It was going down and it hit 0, 0. So it's this one, D. The other one, 4 times x minus 3 cubed and x minus 1. Okay, well, we know that it's a parabola because 3 and 1 is 4. The degree is 4. The leading term is positive, so it's going up. Going up is B or F. Now we could look at this and notice your intercepts. If we set this equal to 0, it's going to hit the x. The zeros are at 3 and 1, because if you set this equal to 0, you get 3. This one gives you 1. This one's hitting the x-axis at -1, so it cannot be f. Notice this one hits at 1 and 3, so it's b. So there's different ways you can look at it and find values, but you could always plug numbers in too. We could plug in 0 and see what we get. So that one was matching graphs. One more. Finding x and y-intercepts given a polynomial. Finding x and y-intercepts right there. Okay. For this one, finding the x and y-intercepts, you need to factor. X cubed minus 3x squared minus x plus 3. We have 4 terms, so factor by grouping. If we look at the first 2, we can pull out x squared, and we're left with an x minus 3. The next one we can pull out a -1, which changes our signs so that they match x minus 3. We pull out the x minus 3, and you have x squared minus 1, which then, well, yeah, we want to factor that. X minus 3. X squared minus 1 is perfect squares, so x minus 1 and x plus 1. So then to find your x-intercepts, you set those equal to 0. So we get, adding that over, we get a 3, a +1, and a -1 for our x-intercepts. The y-intercept, you let x be 0. 0, you could put it in here if you want, cubed, minus 3 times 0 squared, minus 0 plus 3. Notice it's your constant. Depending on how they want it written, either that point or y-intercept equals 3. But those are your x and y-intercepts. Let's try one more. Okay. F of x equals 2x cubed minus 2x squared minus 32x plus 32. So factor by grouping, we can pull a 2x squared out of the first group, which leaves us x minus 1. The next one we can pull a -32 out, which again leaves x minus 1. X minus 1s are the same, or you did something wrong. Come on, what happened? There you go. So the x minus 1s are the same, and we're left with 2x squared minus 32. You can set x minus 1 equal to 0 and get 1. Now if you're not sure on factoring, you can use the square root method. We can bring the 32 over and divide by 2. And then we take the square root of both sides. So we have x equals plus or minus 4. You need to be careful though when you take the square root of both sides. You don't want to lose the plus or minus. So your x-intercepts are 1, 4, and -4. To find the y, you're plugging in 0. When you have a polynomial, that drops out, that drops out, that drops out. You're left with the constant. But if we plug it in, 2 times 0 cubed minus 2 times 0 squared minus 32 times 0 plus 32 equals a y-intercept of 32. It does want you to, you don't have to write the points. It says to list them with commas, so you would just put commas. But that's all that's to it. I think that was all 3. Finding the x. Yep.